All right, chemistry, this is the answers video to the day 33 lesson. It's the first of 3 lessons on stoichiometry, and it has to do with one-step conversions from moles to moles or grams to moles. So I gave you a page that just kind of summarizes what we've talked about in the past about why this is important and what's going on here. So let's just go ahead and read through this. So stoichiometry is the study of conversions from the language of chemical equations to the measure we make in the real world, such as grams of solids or liters of gases. A mole is 6.022 times 10 to the 23rd. Usually, this refers to a number of atoms or molecules. The chemical equation below can be read: 2H2 plus 1O2 produces 2H2O. So that can be read as 2 hydrogen H2 molecules plus 1 O2 molecule will produce 2 H2O water molecules. If we multiply everything in this equation by 6.022 times 10 to the 23rd, then we can read the equation as 2 moles of hydrogen gas, H2, plus 1 mole of oxygen gas, O2, will produce 2 H2O water moles. And of course we use moles because they are a number of atoms or molecules that's big enough for us to see and measure on a scale. So we can actually see and weigh 1 mole of H2O so that the equation is speaking to us in amounts that we can understand, that we can use in the real world. Okay, so molar mass. But we can't count a mole of atoms or molecules, so how do we know we have a mole? And that's because we can use the mass, the weight. Think of mass as being weight. We can do this by using the mass in grams of 1 mole of an atom or molecule. So here are the molar masses of some common atoms or molecules. So we've done all this before. 1 mole of hydrogen atoms, that's not H2 gas, but hydrogen atoms, is 1.01 grams. So it's the same as what you see on your periodic table. 1 hydrogen atom would be 1.01 atomic mass units. That number, 6.022 times 10 to the 23rd, 1 mole, would give you the same number, 1.01, but in grams. 1 mole of water, 18.02 grams. 1 mole of methane gas, CH4, is 16.05 grams. So because we can measure grams on a triple beam balance scale like we use in our classroom, we can calculate the number of moles. So the scale allows us to measure in grams. The molar mass conversion is a translator. The molar mass relates the moles the equation uses to grams people use. And the equation tells us how elements relate in terms of moles. So anytime we want to know a relationship between elements, we have to have the numbers in terms of moles and use the chemical equation. That tells us we're going to have 2 moles of hydrogen gas is going to produce 2 moles of water, for example. Equations don't understand grams. You can't put grams into a chemical equation. So we convert from grams to moles to use the equation, and then if we need to know grams of our final product, we need to come back out from the equation back into grams, and we use the molar mass conversion for that. Okay? So we're going to go ahead and do a couple of these. This is a fairly short assignment. So I told you to eliminate these problems down here because they go from moles to grams. That's actually going to be the day 34 assignment, and moles to grams day 34, so I didn't correct that or change that. So we'll skip those. So we'll do A, and B is the one we did in class together. So let's go ahead and do this. Let's look at this. We'll do A first. So you have 2 moles of Ag plus 1 mole of H2S, hydrogen sulfide. Now, it means you need twice as many moles of Ag as you have moles of H2S. It doesn't mean you have to have exactly 2 moles of Ag and exactly 1 mole of H2S. Otherwise, it wouldn't be a very useful equation. So if you want to react 200 moles of silver, then you need 100 moles of H2S. 2,000 moles of silver, you'd have to react 1,000 moles of H2S and so forth. Okay, so we have the molar mass conversions here. Those are our translators. So there we are right there. We measure things in grams on the scale, but then we need to translate to get them into numbers of particles, numbers of moles up here. All right, so the way we do these problems is you simply read the question, how many moles of H2S are required to produce 3.5 moles of Ag2S? So what we're looking for is some number of moles of H2S. That's our question mark. That's what we want to know. So what you do is you go up to the moles row and you'll find H2S. So They're right there. It's right there. H2S and moles. So that's your question mark. That's what you're trying to find. Now, are required to produce 3.5 moles of silver sulfite. Okay, so again, it's moles, unit of measure, and the substance is Ag2S. So we come up here, we're in the moles row, and there's Ag2S, so that's where the 3.5 goes. So the path we need to get us is a one-step conversion. It's from moles to moles is a one-step problem, okay? So what we're simply going to do now is way over on the right, that's where you want your final answer. That's your question mark, what you're trying to find. So I'm going to write an equal sign, underline, and moles of H2S. Okay? Now, over on the left, you start with what you know, and what we know is 3.5 moles of Ag2S. So I'm going to start way over here. Now, I'm leaving a lot of space in the middle. I don't really need this much space on this problem, but many times when you start a problem, you don't know how much space you're going to need. So you just leave a lot of space there, okay? All right. So what we're going to do now is, we see it's a one-step problem, so that means we need one box. So times one box here, okay? And we're going to put a ratio in there. So what we need to know first is our equivalency. And our equivalency is simply between moles to moles is you simply get it out of the chemical equation. There's one H2S, one Ag2S. So the way you would write that is you just add the word moles because it's in the moles row. 1 mole H2S equals 1 mole Ag2S. So I'm going to write that down here. Okay, there it is. Now from that you can derive two conversion factors, okay? And all it is take one of these and put it over the other, and then flip it over. So we'll start, it doesn't matter which is first, 1 mole H2S. I'm going to write it over here in the margin because I did not leave enough space in these problems. I do on the future assignments, so you won't have this issue. I'm going to write it over here. Okay, there it is. So this one over this one. There you see it there. Now we're going to flip it over. Okay, and there it is now. This one over this one and that one. So what you have to do now is you have to pick one of these two to go in that box. So this is where students get hung up, is this choice that you have to make between one of these two. So the way you simply look at it is 3.5 moles of Ag2, it should have been S, is on the top. If you don't see a fraction, it's on the top. It's up in the numerator. It's basically up here. So if you want that to cancel out, which you do because it's not in your final answer, you want it to be on the bottom here. The other reason you're going to choose is that whatever ends up here on the top of the last conversion, and there's only one conversion in this problem, has got to be your final unit of measure, moles of H2S. So which one of those you can use either piece of reasoning there that you want. Which one is going to do it? It's going to be this one. It's 1 mole. So what you're canceling, and this is something students are getting confused with, you're canceling only units of measure. You're not doing anything with this number right now. It's moles, the unit of measure, and the substance cancels down on the bottom with moles of Ag2S. It's just like you can cancel x over x in math class or 4 over 4 in math class. You can cancel the same unit of measure. It has to be the same unit, moles, and it has to be the same substance. So the other reason that this was the correct one to choose was the last man standing, this unit that doesn't get canceled out, is the one you want in your final answer. If that is not the same unit as this, moles of H2S, then you set the problem up wrong. You chose the wrong conversion factor. Okay? So now we're ready to do the math, and this one's pretty easy. And you multiply everything on the top and divide by everything on the bottom. So everything on the top is 3.5 times 1 right there. And then you divide by the 1 on the bottom right there. And what you end up with, of course, is 3.5. Okay? And that's it. That's your final answer. So that's the number that would go there. And you can, so what you're saying is the relationship for every mole of H2S you put in, you're going to get 1 mole of Ag2S out. So if you put in 3.5 moles of H2S in, you're going to get 3.5 moles of Ag2S out. That's what it's saying. All right, that's it. Let's go on to the next one. This is the one I did with everyone in class, but in case you weren't there or missed it, let's do this. Now, you can use all the space down here because we're not going to do those two problems. So what you want to do now, take your graphic organizer and erase the 3.5 and the question mark and even the arrow, because you're going to put it in different place this time. So how many moles of H2? So right away I can go up here, I find moles row, and H2 is over here, so that's the question mark. I want to know how many of those will be produced by 5.41 moles of Ag. So again, moles row, and now I find Ag, it's right there. Okay, so here's what I know. Here's what I don't know, so I'm going to just draw an arrow straight across like that. Okay, and there you go. All right, so let's go ahead and set up our equation over here. We're trying to find moles of H2, so way over here on the right. Again, mole, parenthesis H2, moles of H2. And this is where your final number answer is going to go, so you put an equal sign and an underline there. Now we come over here. 5.41, it's moles of Ag. Okay, and since it's just a single arrow, you don't change directions, just one arrow from here to here. You don't care about, by the way, H2S and Ag2S in this problem. Okay, it's a totally different problem. You're not interested in those two anymore. You're just interested in this and this. Okay, so it means it's a one conversion problem, so it's a one box problem. And it's going to be some ratio there. Okay, so what is the equivalency that relates this box to this box, this substance? It's 2Ag equals 1H2. Again, you just add the word moles there. So I'm going to write it here. It's 2 moles Ag equal 1 mole H2. Okay, that's the equivalency. Now, since I have space to play with down here, I'll come write it down here. So we're not doing this problem at all. This has nothing to do with it. So I'm going to come and put this one over this one. It doesn't matter which one goes first. Okay, so one over the other, and then you just flip it over like that, okay? All right, so which one of these two is going to go in that box? Think about what you need to cancel out and what you want to appear in the final answer. And the other way to simply think about it is whatever's here, moles Ag has to be on the bottom here so they'll cancel out, okay? So that's going to be this one right here. So moles of Ag cancels with moles of Ag. The last man standing is moles of H2, which is what you have in your final answer, so you know you set the problem up right. So now it's 5.41 times 1 divided by 2, and we'll just go one place after the decimal. We're not going to worry about significant figures here. It's 2.7, and that would be that. So that's your final answer there, okay? All right, we'll move on to the following page. These are some review problems, so I'll do a couple of these, but not all of them. I'll do the first two. I think maybe we did all these in class. I can't remember. I'm going to do the first two. Okay, so HI. So you do your calculations down here. So you need to have a periodic table. All right, so we're going to figure out the molar mass of HI. There's one hydrogen at 1.01. Iodine is 126.90. So it's 127.91 grams, so that's the molar mass. It's a mass of 6.022 times 10 to the 23rd hydroiodic acid molecules. So the equivalence is going to be 1 mole. The short Okay, so there it is. You take the equivalency one over the other and then the first over the first. Just a review of what we've done before. We'll do one more here. So nitrogen 14.01, 3 oxygen, So that's the molar mass, so we'll put that here. Okay, there it is. There's everything. Equivalency, conversion factors that you get from the equivalency, the shorthand. That's often the way you'll see it written in a problem when you read a problem. Just like this, okay? All right, down here, we're going to just do 2 of these. Okay, so formula, so Ca and Cl. So Ca is the second column. That means it's going to have a 2+ charge. It's going to give up 2 electrons. Cl is a halogen. It's going to gain 1 electron, so that's a 1- charge. Again, you can get your 60 your charge number by ion sheet out if you want. So you need 2 chlorides at 1-. 2 times 1- is 2-, to match up with the 1 Ca at 2+. Kn. So potassium is going to lose 1 electron to be like the nearest noble gas, which is argon. And nitrogen has got to pick up 3 electrons, 1, 2, 3, to be like the nearest noble gas is neon. So this is a 3- charge. This is a 1+ charge. So again, you use the crossing arrows, and what you're going to get is K3, N1, but you just write the N, okay? And nitrogen, you just change it to nitride. Okay, and we'll do one more. Fe. So it's telling you it's the 2+ charge, not the 3+ charge. So there's that. And oxygen is a 2- charge. So those match up 1 to 1. 2+, 2- even out. So it's just FeO. And I'm going to dispense with the old-fashioned names, the cuprics and the ferrics and the ferruses. Let's just go with the way we normally write it, which is going to be, iron 3, or it's going to be 2, iron 2, oxide. That's that. Okay, and you do the last one. All right. Okay, that takes care of this answers video for the day 33 assignment.